Hey guys, so in this video we're going to be talking about arithmetic progressions. Now over here, let's consider the following sequence. Here I have a sequence of numbers. So I have 1, 4, 7, 10, 13, 16, 19, 22, 25, and so on. Here I've shown the first 9 terms of this sequence. Now one thing we notice straight away is that if I take the first term and I add 3 to it, I get the second term. If I add 3 to the second term, I get the third term. So what we can say is that the difference between each term and the next term is just 3. If I add 3 to the first term, I get the second. I add 3 to the second, I get the third, and so on. So the difference between each successive term and the previous term is equal to plus 3. This type of a sequence, where we have a constant difference between each term and the next term, this type of a sequence is known as an arithmetic progression. This type of sequence is known as an arithmetic progression or an arithmetic sequence. And the difference between each successive term and the previous term is known as the common difference. So in this particular case, the difference between each successive term and the previous term is equal to plus 3. So we say that the common difference is plus 3. And we usually use the letter D to represent the common difference. So here, if we look at the first term, we look at the first term of the sequence. The first term is just equal to 1. The second term of the sequence is equal to 1 plus 3. The third term of the sequence is the second term plus 3. So that's 1 plus 3 plus 3. So that's 1 plus 2 times 3. The fourth term of the sequence is 1 plus 3 plus 3 plus 3. So that's 1 plus 3 times 3. So what we see over here is that, for example, if I want to find the fourth term of the sequence, I take the first term and I add the common difference 3 times. I add it once, I get the second. I add it twice, I get the third term. And I add it 3 times, I get the fourth term. So more generally speaking, what we can say is that if I wanted to find the nth term of an arithmetic progression, I take the first term and I add the common difference n minus 1 times. So here, if I want to find, let's say, the 100th term in the sequence, I add the common difference 99 times. When I do that, I'll get the 100th term. So if I add the common difference 99 times to the first term, I get the 100th term of the sequence. So we can say that the nth term can be written as the first term plus n minus 1 times the common difference. So more generally, if I had an arithmetic sequence in which the first term was a, and let's say that my common difference was d, my second term would be a plus d. My third term would be a plus d plus d. My fourth term would be a plus d plus d plus d, and so on. So here I can say that my first term is a. My second term over here is a plus d. My third term is a plus 2d. The fourth term here is a plus 3d, and so on. So again, if I wanted to find any particular term, let's say the fourth term over here, I add the common difference 3 times, or 1 fewer time, to the initial term. So if I add the common difference once, twice, and 3 times, I get the fourth term. So more generally, I can say that the nth term of an arithmetic sequence is the first term a plus n minus 1 times d. So here we have a general formula for the nth term of an arithmetic sequence. Here, Tn represents the nth term of the sequence or the progression. The letter A represents the first term, and D represents the common difference.